Okay, we are going to be learning about cross-sections. So, with the disk method, you can find the volume of a solid having a circular cross-section whose area is pi r squared. This method can be generalized to solids of any shape as long as you know like the formula of the area of the cross-section. Like some common cross-sections are squares, triangles, rectangles, semicircles, and even trapezoids. So volumes for solids with known cross-sections, it can be taken in the perspective of x and y. And so the volume is always the integral of from a to b or c to d, whichever perspective you're using, of the area of the cross-section. It's always the volume of the integral of the area of the cross-section. And the area of the cross-section can either be the area of a square, which is s squared, the area of a circle, pi r squared, the area of a triangle, b times h over 2, or even a, let's say, semicircle, pi r squared over 2. So there's a lot of options that you can use for cross sections, and a lot of options for AP questions to ask you that. To ask you to. And you might be wondering, how do you know what R or S or H is? So when we do an example problem, I'll elaborate more on that. But for now, I really want you guys to be able to visualize this. So I have a resource right here, that depicts very well how cross-sections look on a graph. So like it's basically the graphs here, this parabola looking thing, and if it said that the cross-section is perpendicular to the y-axis, it looks like this. Since the y-axis right here, it's gonna stack. All these squares are gonna stack right next to each other to fill up this whole section. I forgot to mention how if the question asks you, or if the question tells you that the cross-section is perpendicular to the x-axis, you use the perspective of the x, and if it's perpendicular to the y-axis, you look at this formula, working with y's. So that's it for now, and I'll catch you later with example problem.